With 2.5 million daily users, the Tor network is the world's most popular system for protecting internet users' anonymity. For more than a decade, people living under repressive governments have used Tor to hide their web browsing habits from electronic surveillance. And websites hosting content that's been deemed subversive have used it to hide the locations of their servers. MIT researchers have now demonstrated a vulnerability in Tor's design. They say that an adversary could infer a hidden server's location or the source of the information reaching a given Tor user by analyzing the traffic patterns of encrypted data passing through a single computer in the all-volunteer Tor network. Fortunately, they also propose defenses. The representatives of the Tor project say they are evaluating their fixes for possible inclusion in future versions of the Tor software. According to the researcher, anonymity is considered a big part of freedom of speech now. The Internet Engineering Task Force is trying to develop a human rights standard for the Internet, and as part of their definition of freedom of expression, they include anonymity. If you are fully anonymous, you can say what you want about an authoritarian government without facing persecution. Sitting atop the ordinary internet, the Tor network consists of internet connected computers on which users have installed the Tor software. If a Tor user wants to, say, anonymously view the front page of the New York Times, his computer will wrap a web request in several layers of encryption and send it to another Tor enabled computer which is selected at random. That computer, known as the guard, will peel off the first layer of encryption and forward the request to another randomly selected computer in the network. That computer peels off the next layer of encryption and so on. The last computer in the chain, called the exit, peels off the final layer of encryption, exposing the request's true destination, in our example, the New York Times. The guard knows the internet address of the sender, and the exit knows the internet address of the destination site, but no computer in the chain knows both. This routing scheme with its successive layers of encryption is known as onion routing, and it gives the network its name Tor, which is an acronym for the onion router. In addition to anonymous internet browsing, however, Tor also offers what it calls hidden services. A hidden service protects the anonymity of not just the browser but the destination site too. Say, for instance, that someone in Iran wishes to host a site archiving news reports from Western media but doesn't want it on the public internet. Using the Tor software, the host's computer identifies Tor routers that it will use as introduction point for anyone wishing to access its content. It broadcasts the address of those introduction points to the network without revealing its own location. If another Tor user wants to browse the hidden site, both his computer and the host's computer build Tor secured links to the introduction point, creating what the Tor project calls a circuit. Using the circuit, the browser and host identify yet another router in the Tor network known as a rendezvous point and build a second circuit through it. The location of the rendezvous point, unlike that of the introduction point, is kept private. The MIT researchers' attack requires that the adversary's computer serve as the guard on a Tor circuit. Since guards are selected at random, if an adversary connects enough computers to the Tor network, the odds are high that at least on some occasions, one or another of them would be well positioned to snoop. During the establishment of a circuit, computers on the Tor network have to pass a lot of data back and forth. The researchers showed that simply by looking for patterns in the number of packets passing in each direction through a guard, machine learning algorithms could determine whether the circuit was an ordinary web browsing circuit, an introduction point circuit, or a rendezvous point circuit. It can be done with 99% accuracy. and breaking Tor's encryption was not necessary. Furthermore, by using a Tor-enabled computer to connect to a range of different hidden services, they showed that a similar analysis of traffic patterns could identify those services with 88% accuracy. That means that an adversary who looked into the position of God for a computer hosting a hidden service could identify it as the service host with 88% certainty. Similarly, a spy who looked into the position of God for a user could tell which sites the user was accessing with 88% accuracy. To defend against this type of attack, the researchers recommend that they mask the sequences so that all the sequences look the same. That is, need to send dummy packets to make all 5 types of circuits look similar. The Tor project team is considering this fix to include it into their Tor software.